In this video, we're going to look at doing a piecewise defined function, graphing that function, and then how you would actually graph it on Alex. So the example I have here is that we have a function f of x is equal to x minus 3 when x is less than or equal to negative 2, but it's equal to 4x plus 5 if x is greater than negative 2. So over here on the right, I have some paper where I'm actually working this out. And so I'm going to take each section one piece at a time. So I'm going to use red for this section. And then I'll use a different color for the other section. But sorry I wrote over that. So for this first section, I'm only interested in x's that are less than or equal to negative 2. So I'm going to make myself a little table here. And I'm going to put in values. I want to include that kind of break point. So negative 2 is a break point. So I'm going to choose negative 2. And then I'm going to choose some x's that are less than negative 2. Maybe negative 3, negative 4, negative 5. There's no set number, just enough to get an idea of what the picture of this graph looks like. Well, f of x, or the y value, comes from doing the x value minus 3. So I'm going to put x minus 3 here, and this column will be my y values. So negative 2 minus 3 will be negative 5. Negative 3 minus 3 is negative 6. Negative 4 minus 3 is negative 7. And negative 5 minus 3 is negative 8. This isn't all of the ordered pairs on the graph, but it gives me a good start as to what I can actually come over here to Alex and plot. So I'm going to do that. I'm going to come over here to Alex, and I do have or equal to negative 2. So that or equal to means a closed circle. So here at negative 2, negative 5, I'm going to pull my closed circle. There's my closed circle point. I'm going to go to negative 2, negative 5, and I'm going to click. Okay, so now I've got a point there. I can put negative 3, negative 6. I can put negative 4, negative 7, and I can put negative 5, negative 8. Now remember, I don't need all of these pairs. I just actually need 2. Because what happens is we've got a little section here. This is a line segment. It's the line x minus 3. If I let it go through the y-axis, we'd have a y-intercept at negative 3. And we have a slope of, remember the coefficient of x, we looked at linear functions, that's 1. So we see that slope shown here. Up 1 over 1, up 1 over 1, up 1 over 1. So we've got some ordered pairs that can help us graph, but we can also use our thoughts about what it means to look linear. So in both, thinking of it both ways, it works out. So these are not the only points that make this true. These are just some of the points. I need to draw in the part of the line that this graph shows. It's not the whole line. It's just a part of the line. So I'm going to choose, there will be an end point. So not 2 end points, but just one. So I'm going to click this option, and it says place my first point. Okay, so that's my first point, that negative 2, negative 5. That's where this section of the graph ends. Now for my second point, I can pick any of these that I have marked, or even one that I haven't marked, but I've marked several, so I might as well choose one of those. I'll click here, and as you'll see, I have a linear section. Alright, that makes sense because this is a line, and that line goes up to x equals negative 2. Alright, then we switch gears. Now we've got a second situation. When x is greater than negative 2, the y values are found by doing 4 times the x value plus 5. So I'm going to make myself a table. I'm going to choose x's that are greater than negative 2, but I am going to choose negative 2. I think a very reasonable question is, well, Ms. Hall, why don't you start with negative 1? Because that's the first integer that would be greater than negative 2, and that's a true statement, by the way. But if we start at negative 1, we leave out all of the points between negative 2 and negative 1. So what we do is we will use negative 2, but since this is technically supposed to be greater than, not equal to, we'll show that with an open circle at this point. Okay? I'm going to choose a few more x values that are greater than -2. I'm going to choose 0 and 1 as well. This time our y values are 4 times the x value plus 5. So we've got 4x plus 5. Okay? So 4 times -2 is -8, plus 5 is -3. 4 times -1 is -4, plus 5 is 1. 4 times 0 is 0, plus 5 is 5. 4 times 1 is 4, plus 5 is 9. All right? I don't have to have all of these ordered pairs. I need at least 2 of them. But I'm going to come back over to Alex, and now I'm going to graph his second section. I need to have an open circle at -2, -3. So I'm going to grab my open circle. I'm going to go to -2, excuse me, -3, and there I've got a point. Now, the rest of these are actual ordered pairs. They're not open circles. They're included in these x values are greater than -2. So, -1, 1 gets a regular point, we could call it that. 0, 5 gets a regular point. And 1, 9. Oh, I put that at the wrong place. All right, so we will erase that point. Sorry about that. That is where it should be. And the way I knew that wasn't right is I should be having, notice, a slope of 4. And I had something out of whack there. So everything is now back in whack. So we will just kind of double check. Up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1, and so on. I do need to fill this in. I'll choose my section that has a beginning and then it goes on forever. It starts here, and then I can choose any one of these points, because notice once I choose one, it's going through all of them. I'll just choose this one because it's closest, and now I have that connector. Alright, now I have this question, is the function continuous? And it's not, because if I trace along this, I would have to pick up to move to the next section. So the answer is no. If you can trace without picking up your pencil or your cursor, whatever the case may be, then it would be continuous. So when you get done with your graph, if this is a function, remember it should pass the vertical line test. And if you've got lines crossing over each other, somewhere something should have stopped before something else started. So I hope this has been helpful with piecewise defined functions.